friends, welcome back. In the previous video, we had seen the terminal currents of BJT, and we had also seen what is happening with the band diagram of a BJT when the emitter base junction is forward biased and the collector base junction is reverse biased. The term base width modulation was also introduced. In this short video, the base width modulation will be dealt in detail. Let us see what is base width modulation. This term is having another name as base narrowing. And the effect due to this base width modulation is also known as the early effect. In order to understand this in detail, let us consider the block of a NPN transistor. The block of the NPN transistor. Which is connected as common emitter format. This is the emitter. As you all know, we will have the emitter base junction forward biased and the collector base junction is reverse biased by connecting external voltage sources. And we know that since the collector base junction is reverse bias, there will be a depletion region forming at the junction. There is a depletion region forming at the junction between the collector and the base. This effectively reduces the base width, available base width. The base becomes narrow. Now what happens? Due to the applied voltage, electrons are moving into the base, and the number of electrons that will surpass the base and reaches collector is increased due to this narrow base, because the recombination at the base reduces, or the electrons reaches the collector earlier than expected, because the base width is narrow. So the recombination at the base will be minimum. So more electrons from the emitter will reach the collector. This is known as the base width modulation or early effect. Now let's see mathematically how can we represent this effect into the terminal currents. As you all know, the collector current IC is equal to Is e raised to VBE by Vt, where Is is the reverse saturation current and VBE is the applied base emitter voltage, and VT is the thermal voltage. As per the explanation, we know that due to the base width modulation, there is an increase in collector current. If we remember the characteristics, we had a flatter IC when compared to a particular IB, but in this case there will be a slight inclination, which is due to the early effect. And if we plot this backwards, it converges to a point which is the VA, the voltage at which the collector current is 0, IC is 0, because this is IC and this is VC, the VBE. So this voltage VA is known as the early voltage. This is also contributing to the collector current. So including the early voltage VA, we can rewrite IC as IS e raised to VBE by VT into 1 plus VCE by VCE, just the VCE term, by VA. So this is the change happening in the collector current. As you all know, the reverse saturation current IS is inversely proportional to the base width. So that if the base width decreases, the reverse saturation current increases, which in turn means IC increases. And also alpha increases. If alpha increases, beta is equal to alpha by 1 minus alpha, this also increase. So on base width modulation, beta dash, the new, is equal to beta into 1 plus VCE by VA. And we know that IC is equal to beta. Here it is beta dash IB. So IB can be written as IC by beta dash, which is equal to IS e raised to VBE by VT by into 1 plus VCE by VA, all divided by beta times 1 plus VCE by VA. These terms get cancelled, so that IB is equal to IS e raised to VBE by VT by beta. IE, as you know, IE is the sum of IC and IB. So due to the base width modulation, there is an increase in collector current, which in turns increases the emitter current. You have to keep in mind the terms base width modulation, base narrowing, or early effect indicates to the same concept, which is the reduction in base width due to the applied reverse voltage at the collector base junction.